Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Today we are going to know about properties of definite integrals, and these properties will help us a lot in evaluating definite integrals. So let us discuss each property one by one. Here is the first property of definite integrals, that is integral from a to b fx dx is equal to integral from a to b fz dz. Or we can say, if we replace the variable x with some other variable, say z, then the value of the definite integral remains unchanged. Here the function fx and fz, they are of same nature, that is, if fx is equal to sine x, then fz is equal to sine z. Or we can say only the variable is different. The function is same, but the variable is different. Now let us prove this result. For that, let that is derivative of capital Fx is equal to small fx, or we can say fx is antiderivative of small fx. Then equal to small fz. Now we take this integral, that's integral from a to b fx dx. By fundamental theorem of integral calculus, we have this equal to f of x with limits from a to b, which is further equal to f of upper limit, that is f of b, minus f of lower limit, that is f of a. Okay, now we take this integral a to b fz dz. Again, by fundamental theorem of calculus, this is equal to f of z with limits from a to b. So that is further equal to f of upper limit, that is f of b, minus f of lower limit, that is f of a. From these two equations, RHS is same. In RHS we have f of b minus f of a in both the equations. That means the LHS is also same. Or we can say integral a to b fx dx is equal to integral a to b fz dz. This proves the property number 1. Now let us take one more property. Now here is the second property of definite integrals, that is integral from a to b fx dx is equal to minus times integral from b to a fx dx. Or we can say, if we interchange the limits of an integral, that is, if we consider the upper limit as lower limit and lower limit as upper limit, then the sign of the integral get changed. That's, if it is positive, it becomes negative, or if it is negative, it becomes positive. Okay, now let us prove this result. For that, let derivative of capital Fx is equal to small fx, or we can say let capital Fx be antiderivative of small fx. Now consider this integral, that's integral from a to b fx dx, this is equal to, by fundamental theorem of calculus, this is equal to capital Fx, limits are from a to b, so that is further equal to f of upper limit minus f of lower limit. Okay, now we take this integral from b to a fx dx. Again, by fundamental theorem of calculus, this is equal to capital Fx with limits from b to a, that is further equal to f of upper limit is a here, so it is f of a minus f of lower limit, that is f of b. Take minus common, so it is minus times f of b minus f of a. Okay, now from these two equations, here we get f of b minus f of a, and here we get minus times f of b minus f of a. That means they are of opposite sign. So integral a to b fx dx and integral b to a fx dx are of opposite sign. That is, a to b fx dx is minus times b to a fx dx. This proves the property number 2. Now let us discuss property number 3. Now this is property number 3 of definite integrals, that is integral from a to b fx dx is equal to integral from a to c fx dx plus integral from c to b fx dx, while c is a point between a and b. Let me explain it this way. If this curve represents graph of the function fx, and let this be point a here and this be point b, okay, then the definite integral a to b fx dx is the area under this curve between points a and b. That means this area. And let c be a point between a and b. Let this point be here. Then obviously the area under curve between points a and b, that is this integral, is equal to the area under curve between points a and c, that is this integral, plus area under curve between points c and b, that is this integral. Okay, now let us prove this result. Let derivative of capital Fx is equal to small fx. That means capital Fx is antiderivative of small fx. Then integral a to b fx dx is equal to, by fundamental theorem of calculus, this is equal to f of x with limits from a to b, that is further equal to f of upper limit minus f of lower limit. Okay, now we take this integral, it is a to c fx dx. This is equal to fx from limit a to c, and that is equal to f of c minus f of a. Again, take this integral, it is from c to b fx dx, which is equal to capital Fx limits from c to b, and that is f of upper limit minus f of lower limit. Now we add these two equations, this equation second and equation third. If we name this as equation first and this as equation second and this as equation third, then adding equation second and equation third, we get integral from a to c fx dx plus integral from c to b fx dx is equal to, when we add RHS, then this f of c plus and this minus f of c, they cancel, so we get f of b minus f of a. F of b minus f of a. Now we name this as equation fourth. Now from equation first and equation fourth, RHS is same. Here RHS is f of b minus f of a, and here RHS is f of b minus f of a. That means LHS must be same, or we can say integral a to b fx dx is equal to integral a to c fx dx plus c to b fx dx. That completes the proof of property number 3. Okay? Now in my next lecture we will discuss few more properties of definite integrals. Till then, take care of yourself. Thank you.